Hello, everybody in quarantine. We missed you today, and I hope you guys are doing well. What we did in class today, we finished the second half of this um, doodle note on atomic basics. We had done the first page together the other day before you guys went on quarantine. So you should be okay with the first page. The second page we did we did together using the smartboard today. So let's go through and I'll explain this real quick. And if you have any questions, you can email me and let me know. First, we talked about the periodic table and how important that is to science. And basically, what it is, it's a grouping of all of the known elements, and they are listed by, their atomic number, which is that little number right up there above the letter. And that tells you how many protons there are in an atom. And that number never changes. That number stays constant. Here's an example over here where rubidium has 37 protons, always, always, always. And whenever you find an atom with 37 protons, it's always rubidium. If you had one more proton, it would be a completely different element. So these are listed by their atomic numbers, but they're also in important groups. So, like for instance, the grouping here along the side, those are all gases. And then you've got metals all over here and just different kinds of elements. And when you get to chemistry, you're going to need to know all of those groupings, and it'll help you figure out how to use the periodic table to work on chemical reactions. Basically, what we need to know for biology is we need to be able to use the periodic table to talk about organic molecules and molecules that are important for your body and your nutrition and what you're made up of. So we'll be using the periodic table that way. So in order to understand what one of the entries looks like, we already said this was the atomic number here, 37 for rubidium. This is the chemical symbol, rubidium, and I know you guys had to learn those last year at the middle school. So hopefully you remember a little bit of that. And this little number down here, that's the atomic mass. So that's the number of protons plus the number of neutrons. And that gives you an idea of how much mass is in that particular atom. This one has a mass number of 85.4, so it's a fairly heavy element. Also, we talked about bonding and how important that is to molecules that make up your body. Most of the time, we're going to be talking about compounds more than singular atoms. A compound is made up of two or more elements that are chemically combined. So they're combined together with some type of bond that holds them together. And here I have three examples of bonds. The first one is a covalent bond, and that's when you have two atoms that are sharing an electron, and the electron kind of does like a figure eight and goes, all the way around both nuclei, the nuclei of each one of those atoms there. So it kind of satisfies the need to have that number of eight valence electrons that we talked about the other day. So this is a hydrocarbon molecule. So you're going to see a lot of those when we're talking about organic molecules. Water also has a bond. It's called a polar bond. Water molecules are bonded together, and basically what happens here is the oxygen part of the water molecule is on the negative side. The positive part is over here where the hydrogens are. So you kind of end up, because of the way that it bonds together and the shape of the molecule, you kind of end up with these weak magnetic poles. So this has a negative pole and this has a positive pole. So the water molecules kind of stick to each other, and that's what gives water all of its special properties, including the fact that it expands as it freezes. So ice actually has a larger volume than liquid water, and that's because it has this polar bond, also known as a hydrogen bond. And then the third type, this is an ionic bond, and this is when one atom actually gives up an electron and another atom takes the electron. And by doing that, these two atoms are bonded together. So you end up with, this is probably the most famous example of that, sodium gives up an electron to chlorine. And what you end up with is sodium chloride, and that's table salt. So that's an important ionic bond that you have there. We'll talk about a couple more bonds when later on in the unit, but those are the most important ones that we are talking about today. Now, I did give the other students a grade for this particular doodle note because we did it together in class. So you should have this paper so you can fill in all of these things from the video and you can get credit that way. Or you can just wait until we get back and you can borrow someone's and fill in the rest of the notes that way. Hopefully you won't be out for too long. Hopefully it'll be the 2 weeks and then you can come back. So the other thing that we are going to do tomorrow is we're going to keep working on that game that I mentioned yesterday. Let me see if I can get us to that game. Yep, here it is. So if you go to your agenda on Canvas, it's on the agenda for today, and it will also be on there for tomorrow, which will be Thursday, November 5th for you. So there's a worksheet. Open up the worksheet, and the worksheet, it has some questions that you're going to be filling in while you're doing the activity on the game. And a couple of places it asks for you to draw, like draw your nucleus, and then down here, draw your atom or your ion. And the way to do that is to use your drawing tools in Microsoft Word. So you've got all of these tools here that you can use to draw your nucleus on. So what you're going to be doing is put your protons and neutrons in 2 different colors, so I can tell what atom that you're going to be putting on there. And same thing here. So you'll be putting on your electrons, and you can put all of those on a different color so that you can be able to tell whether or not it's a neutral, positive, or negative ion. So you're going to fill that out as you play the game. The game is embedded on your Canvas page. So you come to it here, and we'll just open that up. Maybe click on here. Yeah. And now you have the game. So the first thing it asks you to do is just kind of play with it. Like if I take an electron and I try to put it in the nucleus, then the game knows, well, that's not right. So it goes over here in the electron orbit. If you'd rather look at it as an electron cloud, then it looks like that. Well, that one has an X in it because we haven't put anything in the nucleus yet. So let's add a proton into the nucleus. Whoops. Drag it over. There we go. So now we have a hydrogen atom here. And I think we can add a neutron on as well. Whoops, you have to kind of grab it. There we go. And now we have our neutral hydrogen atom. So it has a net charge that is neutral, right? 0, which is what hydrogen is supposed to have. Mass number is 2 because we have a proton plus a neutron. So now we have is it a stable or is it unstable? It's stable. So that gives us a stable element. Then the second part has some questions about the chemical symbols that you can answer by putting your electrons and your protons and neutrons there. And finally, there's a little game to play to make sure that you learned everything that we wanted you to learn by playing with this website. So this is what you're going to use to fill in that worksheet. So if you have any questions, be sure to shoot me off an email. I'll be glad to help you in any way that I can. And hopefully you guys will be able to keep up and stay safe and healthy on quarantine. So I will be seeing you later. Bye.